data is given. Okay. So the primary data is given. Okay, these data are given, and one more additional data is for mild steel 3800 ampere turn will be the flux intensity H if flux density is 1.625 and 850 for 1.3 Tesla. Okay, that we will discuss later. Next we can start with the problem. So for doing problem, our aim is to find what total MMF, that is Ni. Once you got Ni or a total MMF, then divide by N giving you I. Okay. Your aim is to find this first total MMF. Then divide by number of turns give you the current. So total MMF is given by this equation. MMF EDA equal to Na equal to MMF AM plus MMF MD plus MMF AF. So first we can find the total MMF. Section AD, that is this section. Okay, this first you need to find MMF in AM plus MMF in MD. So first we can find MMF in MD. Okay, next we find the MMF in, that is this portion. For that we know flux in the is given. The question flux in the central limb is given as 3 milliweber, 1.3 into 10 raised to minus 3 Weber, and A the section is 800 millimeter square. So 800 into 10 raised to minus 6 square. So what will be flux density? B equal to 5 by, equate the value. What is the value? Flux is 1.3 into 10 raised to minus 3 by 800 into 10 raised to minus 6. You will be getting 1.625 Tesla. Are you getting this value? Yes. Next, for corresponding to 1.625 Tesla, what will be your H? For 1.625 Tesla, your H equal to 3800 ampere turns per meter. Okay. So corresponding the value of H for flux density is given as 3800 ampere turn per meter for 1.625 Tesla. Refer your question. Since the length of central limb is 120 millimeter, what is the MMF H into L? So 3800 into 120 into 10 raised to minus 3, that is 456 ampere turn per meter is the MMF of this section. So how will you find MMF? H into length. MMF of this section MD equal to, this is your point M. MD equal to H into length. H is magnetic field intensity that you obtained by finding flux density. Flux density is 5 by area. Phi is given, area is given, so 5 by area is 1.625 Tesla. Correspondingly, you get 3800 ampere turns. Multiply this by, you will be getting 456. Next section, you have to find MMF in section AM. So next to find MMF in section AM, that is the air gap MMF, which is air gap part. So for that section, we know that the air gap flux density is same as the central limb flux density. Up to this point, flux density is same. Therefore, what is field intensity? Flux density by mu 0. B equal to mu 0 H. So, B by mu 0. B is 1.625 Tesla. We have already got 4 pi into 10 to the 7 is mu 0. So, you will be getting the value of 0.1293. Once you got H, how will you find mm of H into L? What is the length? 1 millimeter. So, mm of length of air gap is 1 millimeter. So, of required is H into L. So, 1293 ampere turn is the total mmf of which section? AM. So, total mmf of section AM is 1293. So, you got the mmf of two sections. MD is 456. This section MD mmf is 456 ampere, and for section AM mmf is 1293 ampere turn per ampere turn. If you got the value, next we have to find the mmf of third section AFED. So for finding mmf of section AFED, that is the third path, to find the mmf of AFED. This is the third path. For this, we know that flux phi is linking with the central limb. This flux, similar to current, split into two parts. Since each part is having same length, the same area of cross section, therefore flux linking with the both part is same. So flux is divided into two paths, phi 1 and phi 2, and that is phi by 2. This is the total flux in the central limb, phi divided by 2, that is 1.3 into 10 raised to minus 3 Weber by 2 will be the flux in the each limb. Why we are taking it as same value? Because length, area, everything will be same for both part. That is why flux will be same. So flux density is flux by area. We know that area of that limb, sides 500 millimeter. So flux density by area gives you flux by area gives you the flux density 1.3 Tesla. Next, you see your question for corresponding to 1.3 Tesla. What is the value of H given? See the question. For corresponding to 1.3 Tesla, the H value is 850 ampere turn per meter. So you have to take the value. So corresponding to H flux density, the ampere turns per meter is, or field intensity is 850. So H you got. Once you got the H, what will be the of H into length? Length is 300 millimeter into H is 850. So total is 255 ampere turn. Since the mmf is same as in parallel path, opposite parallel path also, that is A, B, C, D, this path, both are same. So you find the total mmf as AFED. mmf in the total path is given as mmf of AFED A is given as mmf of AFED plus mmf of AM plus mmf of MD. So add these three values, 456 plus 1293 plus 255, that is 2004 ampere turns. Here there is a correction, flux through ABCD. They have taken ABCD, but I have taken AFED. Both are same. ABCD and AFED both are same. Okay. So since number of turns in the central limb is 500, current required to set up the flux is total mmf, that is we change to 4 by number of turns 500 and equal to 4001 ampere. Thank you.